Consider the following application example. A ball is thrown straight upwards. The function is given as s of t is equal to negative 16 t squared plus 72. This describes the ball's height above the ground, s of t, in feet, t seconds after it was thrown. What is the instantaneous velocity of the ball 3 seconds after it was thrown? All right, in order to determine our instantaneous velocity, we have to find the derivative of this function, s prime of t. And we're going to use our limit as h goes to 0 of s of t plus h. So you can see I plugged in a t plus h here into our function, FOILed that out to obtain that, plus 72 times t plus h, as you see here, minus s of t, the function itself, all over h. So now we have some messy algebra to contend with here. We're going to take the limit here as h approaches 0, distributing our negative 16. We obtain negative 16 t squared minus 32th minus 16h squared plus 72t plus 72h. Distributing our minus sign, we obtain 16t squared minus 72t, that all being over h. Now, the nice thing about this problem, we have some like terms to cancel out. We got a minus 16t squared to cancel out with a plus 16t squared. As well, the 72t's cancel. And if we quickly factor out an h, as we take the limit here, we have h times a negative 32t minus 16h plus 72. That will all be over h. So now the h's cancel. Once we take the limit, as h goes to 0, we see that this negative 16h term goes to 0, and we've done it. We have a negative 32t plus 72 for our derivative, and this is equal to s prime of t, the derivative of our function. Now, this gives us the instantaneous velocity of our ball as it goes up into the air. We want to find out when that occurs, what that is actually at t equals 3 seconds. So we have s prime of 3 for this problem we're evaluating. We get a negative 32 times 3 plus 72. And so from this, we end up with an instantaneous velocity of a negative 24 feet per second. So we've done that here. Our instantaneous velocity is negative 24 feet per second.